Hey, grade 11s, just before we carry on with question 2 of the TRIG test that you wrote last week, I just want to correct something from question 1. I didn't quite finish. Question 1.2.3, we managed to simplify cos squared of 90 plus beta into sine squared beta. Okay, but because we've got a Cartesian plane and we've got a scenario and a story that describes this TRIG situation, we have to be able to substitute values into sine at this stage. So just to continue and get our final answer here, sine squared beta is y over r all squared. So we're going to find the y value from our story here, which we worked out our t value there was y, our y value. So it's going to be negative 5 is y over r, which is root 34. That now describes what sine beta is, and we're going to square the whole thing. So by squaring negative 5, we're going to get 25, and by squaring root 34, the root and the square are going to cancel, and we're going to get 25 over 34. Okay, so that just needed to happen from 1.2.3, just to go one step further in our answer. Apologies about that. Okay, we now move on to number 2, or question 2, which I've written the first part out for you. In 2.1 it says prove that cos x over 1 plus sine x plus tan x is equal to 1 over cos x. So these are identities where you are required to prove that the left hand side is equal to the right hand side, and they can be quite tricky because it involves various things that you could do. So the way we set these questions out is we say, first of all, let's work with the left hand side. Okay, hopefully after a whole bunch of steps we're going to eventually say equals right hand side. That is our target. We are hoping that the left ends up being the right. Okay, so you'd also notice that you're adding two terms together, okay, which is important. Tan x is also going to be able to be written as what? There is the quotient identity, or that you've learned in the last week or two, that describes tan x rather as sine x over cos x. Great. So you've already got your first mark by bringing in that rule. Okay, the next step now is, because we are adding two fractions together, we have to find for ourselves a lowest common denominator. So the two denominators that we have at the moment are 1 plus sine x and cos x. So we are going to make a denominator that combines both of them, cos x, 1 plus sine x. Great. So that denominator there was missing the cos x. So if we've times the denominator by cos x, we must times the numerator by cos x. Cos x therefore becomes cos squared x, right? This numerator of plus sine x will need to be times by a 1 plus sine x. Happy. So we've successfully now used the LCD and multiplied with what was missing. Right. Now to times out, and I'm going to just go to two lines just to make it a bit more clearer here. Cos squared x is just going to stay like that. Now we're going to multiply this sine x into the bracket to give us sine x plus sine squared x, right? We need not multiply the bottom into the bracket because chances are we're probably going to cancel something out. At this stage, after multiplying out, we've noticed that cos squared x plus sine squared x is actually equal to 1, right? That's your circle identity in action. What is left? Sine x. At the denominator, we still haven't changed much here. Cos x and 1 plus sine x. You've now noticed that I can cancel entirely this whole numerator with that piece of the denominator. That does not mean our answer is cos x. We've got 1 left at the top over cos x at the bottom. Now, if we look at what our right-hand side must be, we can see it's the same, equals right-hand side. Please, whenever you do questions like this, keep your eye on the right-hand side. The steps that I used here, I'd used them intentionally so that I would get to my right-hand side. Okay, so 2.1 is done. Identities, I hope that discussion also assists you there. Right, we then move on to 2.2, which is also a bit of a tricky question. Let's work through it carefully. And I know a lot of you didn't like this question, so let's go through carefully. Question 2.2, let me just get the question for you. Says, determine the general solution. Okay, so we've got a general solution here, which is what we've been doing quite recently. 4x in sine 3x minus 2 cos 3x equals 0. Okay, so we first need to get this equation into a certain position before we can say shift and work out angles. Okay, so the immediate thing that I notice is that the angle that we are dealing with in both the sine part and the cos part is 3x, which is good. So we are first going to say, hey, let's leave the sine 3x on the left-hand side and move this whole term to the right-hand side. I would then get sine 3x is equal to 2 of cos 3x, right? Once again, note that the angles are the same. Because the angles are the same, I can divide this cos 3x on this side here. So sine 3x divided by cos 3x equals what is left now on this right-hand side? The 2 is left. Okay? So sine 3x over cos 3x is what? Tan 3x is equal to 2. So immediately now we have we've gone from 2 terms into 1 term, and we are ready to find the general solution. So we are now going to say shift tan, and we're going to pick up our reference angle. So the reference angle 3x is equal to, if we go shift tan 2, we are going to get 63,43. And just to note before I continue, tan of the angle is positive. So when is tan positive in our cast diagram? It's positive in the first quadrant and the third quadrant. Note also that the tan corners or quadrants are immediately 180 degrees opposite each other. And the period of a tan graph is 180 degrees. So we need not deal with both quadrants. We need only work with one and be done. We need not talk about quadrant 3. Okay, so the last step here to do is to divide everything by 3. 63,43 divided by 3 gives you 21,14. And we'd also need to divide the 180k, and we would get 60k. Also add in your answer somewhere, k is an element of z being integers, because that's also an important part of our solution. Okay, so there's the general solution for 2.2.1. I know some of you had difficulty with that. I hope this explanation assists you. The last question, 2.2.2, says write down the specific solution to the equation if x, look carefully at this here, if x lies between negative 90 and 0. So using your general solution that we worked out in 2.2.1, what answers will fit in this interval, in other words? So the first value over here, 21,14, does it fit here? No. If we add 60 here, we're going to get 81,14. Does it fit in our interval? No. You remember, we could also minus 60 from 21,14 because that k could be a negative 1 as an integer. If we subtract 60 from 21,14, we are going to get x of negative 38,86. Does that value lie in our interval? Yes. So there is one specific solution that fits within that interval. Can I subtract another 60 from here? I'm going to get to negative 98,86. Does that fit within our interval? No. So there is our answer for specific solutions. Okay, I trust that this question 2 discussion assisted you. I'm going to hopefully make a few more videos later this week.